Let's build a simple C++ FireMonkey 3D application from scratch. I'm going to select a new multi-device application C++ wizard, and there is a number of templates. One of the templates is a 3D application. You may think that that's a good starting point for a 3D application. If you click on OK, you will get an empty application that is based on a form 3D class. So in fact I would not recommend using this class because it does not provide all the functionality especially related to touch, multi-touch and gestures that are very useful on mobile platforms, and instead I would rather use a regular blank application. So I'm going to close this project without saving it, and I'm going to start again with creating a new multi-device C++ project, but this time I'm going to start from a blank application template. I'm going to save this application in a convenient location, so I'm going to create a folder for it. So Earth and Mars demo, and I'm going to save all the files, giving the project the proper name, Earth and Mars demo. Okay, so now I have just a 2D form. In order to use 3D components, I need to put on the form a T viewport component. So T viewport component you can find on the tool palette, but probably that's the easiest is to directly type it in here, the name of the T viewport component, and add it to the form. So I want to make sure that my viewport occupies the whole screen, so I'm changing its align property to client, and I'm going to build a deep space visualization. So I'm going to change the color from white to black, so it's more looking like cosmic world. So let's start with adding some more components. So I'm on the 3D scene category. There is a T dummy component. I'm going to add it first because it's going to be a main container for all other visual components that I'm going to add. Let's add two 3D objects, two spheres. So I have added two spheres to dummy. So notice in FireMonkey it's very important to look at the structure view and to see which component owns other components. So I'm going to make sure that both spheres are owned directly by dummy. I'm going to change the name of the first sphere to sphere Earth and the second sphere to sphere Mars. Okay, but they are both in the very same location, so I'm going to change the position of the sphere Earth to be X position to be -1, so it is moved a little bit away from the center of the dummy component, and Mars in the opposite direction, X equals 1. So notice that this is the position, and other things like space, like rotation angle, are relative to the containing object. So if I change the position of a dummy component for a moment, the whole scene will go with it. So also the same thing for example, things like rotation angle. If I change the rotation angle of my dummy, the whole scene will be changed. So this is very useful technique. Okay, so I'm going to use some materials. So I want to add a Earth and Mars texture to both spheres. So I have added two texture material source component. The first will be called texture material source Earth, and the second one will be called texture material source Mars. Okay, so in the first I'm going to load a texture image that I have downloaded from the internet. So I have it already in my picture. So the first will be Earth. Okay, click on that. Looks beautiful, and the second one will contain the texture of Mars. Okay, so I'm going to go into the Mars, and that looks okay as well. So now the next step is actually assign these textures to individual spheres. I'm clicking on a sphere Earth and changing its material source property to Earth and the other one to Mars. So now it looks okay, but it is kind of small. So I'm going to select dummy and change its scale to be somewhat bigger. So I'm going to change X and Y and Z to 3, so the whole scene actually got bigger. So that looks already quite nice. Let's see how it looks when we compile and run the application. So yeah, we have a 3D visualization of Earth and Mars, but it is very static. So let's add some movement. So I'm going to make my Earth to rotate and to spin. So there is a number of different animation components I can use to animate different types of properties. I'm going to add a T-float animation component to the form, but I want to make sure that it is owned by the sphere Earth. Okay, so now if I open the property name, property of float animation, I see all the properties of type float that belongs to sphere. I'm going to change to manipulate the rotation angle Y property, and I'm going to set some properties. So loop to true, enable to true, duration to 1 second, start value 0 is okay, stop value minus 360. And now if I run the application, it's always good to save. If I run my application again, my Earth is nicely rotating. Okay, that's a good step. We have some movement. Our user interface gets more interesting. So let's add some interactivity. Let's say that we want to move when the end user clicks on Earth. We want to make it a little bit closer to the viewer, and if it clicks again, it will go back to the original position. So in FireMonkey 3D, there is a 3D coordinate system. So X direction goes to the right, Y direction goes to the bottom, and Z direction goes into the screen. So if I want to make my sphere Earth a little bit closer, I want to change its property to something like -2. So that's something I'm going to do programmatically. There are different events. I'm going to add an event handler to the onClick event and change the position of the sphere Earth. So if my sphere Earth position Z is bigger than -1, for example, it's 0, then I'm going to make it closer to the user. So I'm going to change it to something like -2 to make it closer. And in other case, we want to move it back to its original location. So I'm going to set this value to 0. Okay, how it works. Let's run it. Okay, no, it does not work correctly. I must have done something wrong. So if sphere Earth positions, okay, I should make it equal, not bigger. Okay, I'm going to save it again, run it, and see. Oh, this looks nice, but it's not as smooth as I would like to have it. Let's add an animation. So instead of changing this position Z property immediately, I'm going to animate it from the value 0 to -2. So how do I do it? I'm going to comment out these two lines of code, and I'm going to use a special T-animator class. So this animator class has different methods, actually class methods. So I'm going to use this to animate different types of different properties of different objects. So T-animator, T-animate float takes an object that I want to manipulate. I need to specify the name of the property I want to change. So this is just a string, and I need to provide a new value that it will get. Actually, there are more functionality. This is an overloaded method, so I could specify the duration. By default, it takes just 1 second to change the position. So now my animation should look much better. So let's see what we have achieved. So okay, so now my Earth is actually moving nicely. Okay, so the next step will be to be able to change the view angle or the position of the viewer that looks into the scene. So I would like the functionality to make it even more interactive. So if the end user is using mouse on desktop or touch on mobile platforms, I would like to change the view point from which we see this scene. So I need to add some functionality here. So I'm going to use an explicit camera component. So before I add the camera component again, I'm going to use this very useful dummy component. So I'm going to select viewport 3D and add it to a second dummy component. So this dummy component will be owner of my camera. I'm going to change the name of this dummy to XY, and I'm going to add to this dummy XY component a explicit camera component. I'm going to change the name of the camera to Z. Why I'm doing this? So basically the point here is that I can just change the orientation of the dummy XY component to change the orientation of camera in 3D space. So for example, if I change the rotation angle of dummy XY, I can, for example, to let's say 15, my camera is actually pointing in a different angle. So in this way I can actually change, just by changing rotation angle X and Y, I can change the position of the camera, and it will be always looking into the middle of the scene. So that's very useful. I'm also going to manipulate the location of the camera by changing its Z property, so our scene will look bigger or smaller. Okay, so we have good components in place. Now we need to add some functionality to it. But before we do it, we need to connect the camera to the viewport. So without a camera, we still can visualize the 3D world. So viewport has a property called camera. So I need to assign this camera that I have added. I could have more cameras in more generic situation, and also there is a property using design camera. I need to set it to false to actually use the camera component that I have placed on the form. So the viewport has a built-in camera that you use if you don't have an explicit camera, so it's quite critical to set this using design camera to false. And now I'm going to add some code to change the location of the camera in response to the user events. I'm going to add two events, so on mouse down and on mouse move. So it is mouse on mouse move and on mouse down, but it will also translate nicely into the touch behavior on mobile devices, so it will work across all the different platforms. Okay, I want to define a global, actually the private member of my form, to store the last location of my of mouse. So I'm going to have this f down member of type t.f, so that's just a struct xy struct, and in the code I'm going to just in the mouse down, I'm going to remember where I have actually clicked. So f down will equal point f and x y. So that's a useful function to convert x and y float values into the t.f structure. In the mouse move event, we are going to do the actual rotations. So I want to check if in the shift, if shift contains the SS left enumerated value. So this basically tells me if I'm checking if the end user actually pressed the left mouse button. And now I'm going to change the orientation of my dummy XY. So dummy XY rotation angle, and first I'm going to change the rotation angle X, so that will be the same as it was before. I'm going to copy this code from here, and I need to modify it based on the Y variable. So that's a tricky part, but that's how we should implement it. I'm going to just take the current Y variable and deduct from it the previous y variable, and I know from the experience that it's good to multiply by -3, and in this way we have a nice behavior. The same thing needs to be implemented for the rotation angle y, and this time based on the x property, on the x coordinate. Okay, and again I need to make sure that I store the latest f down location. Okay, let's see what we have achieved. And okay, so I can click on and I can also change the view angle. So notice that this is still interactive, and you can see the Mars and Earth from different locations. So this is actually much better. We can also add code to change how far the camera is from the scene. So we need to change the camera position Z property. So we are going to do it in the on mouse wheel event. So here I'm going to go to the events and the on mouse wheel event. I'm going to actually change the location of the of my camera. Okay, so how do I do it? So basically the wheel delta does not provide a lot of useful information. Typically when the end user make the move in one direction or another, the wheel delta will be something like 120. So we are basically interested in the fact whether the wheel data is positive or not. So we can actually change the location of the camera. So we can do the code like this, that if wheel data is more than 0, we can change the camera position to a certain new step. I'm going to define a constant variable, constant for of type float for the zoom step, and it's going to be 2. And I also want to have a float variable called new z that I'm going to calculate based on the wheel data. So if we have a positive value for wheel data, we say that new z is going to equal the camera z and position z plus zoom step. And in other case we are going to do the same thing but negative. So I need to do some code like this, and I'm going to have a zoom step minus. So we want to have also some maximum and minimum value that we want to assign. So I'm going to define two more variables here. The camera max z, I'm going to make it -2. Notice that we are actually in the negative range of z values here, and the minimal value will be something further away, like -102. So I'm going to, before I'm assigning this new value to position z, I'm going to check if it is in the correct range. So I'm going to do a double check here for if the new z value is smaller than camera max z, and if it's actually bigger than minimal value, then we are going to change the camera z location. So now we can assign it nicely. Take this camera z, copy it here, and equals new z. Okay, so that should do the trick. So now I have some errors. Wheel data undefined wheel. Okay, wheel data delta. Okay, I'm not data but wheel delta. So that should be better. And now let's run this, and we can actually move away, and we still have the functionality to play with our 3D visualization. So that's the demo. The demo source code will be available for download from my blog page. And now let's have a look at the other completed demo that is already pre-built. That will be probably a little bit too difficult to build it from scratch just right now. So this is a Molecule Hero demo. Let's see what it does. I'm going to run it, and it will use the same techniques that I have been demonstrating to visualize arbitrary chemical molecules. So I have different molecules and different modes of visualization. So I'm using a multi-view component. That's a very useful 2D component. So I can, for example, change it to something like this. And I have different modes of visualization. I can visualize atoms and bonds, just atoms, or just bonds. You can also use the handy, either use a wheel or a button to change the visualization. There's also a nice info page that shows that this is a Molecule Hero application. It is available for download from Google Play Store, and there is more information about it on the superlolo.com/Molecule Hero, which is my own project to popularize Delphi and C++ Builder use in a developer community. So you can I'm not going to go into the details of this application. You can go directly to the Molecule Hero GitHub repository. It is implemented in Delphi, not in C++, and you can actually read the code and try to see how you can build some more complex applications that are using 3D programming in FireMonkey. This application is also available for download from Molecule Hero page from Google Play Store.